viewers, welcome to CEC lectures. Myself Dr. Preeti Tigwani from Department of Computer Science, Aryabhat College, University of Delhi. In our previous lecture, we have seen how to include instance method in any class, and moving further, we will be today looking at how to return a value from an instance method to the calling routine, and then we will be looking into some other aspects of instance methods as well. So when we want to return a value, within that, please recall the function, or please recall the program which we discussed, and in that we have one function volume. For just a quick recap, you can have the look on the screen which is having this class box with 3 instance variable, width, height and depth, and there is an instance method volume, and that instance method volume is actually kind of printing the multiplication of width, height and depth, which is the volume. It is actually not returning anything to the we can say calling function. So if we actually want to make this function to return something, for that we need to add a return value, and in order to add a return value, this will be the change in the kind of we can say the class structure, or the we can say particularly within the instance method. So instead of void double volume, this is going to say double, which is the type of the value which we are going to make it return, and then return width, height and depth. So the multiplication of width, height and depth, which are actually the double variables, so multiplication of these three double variables will be a double variable, and that double type variable will be returned. Now let's say we have a called function and a calling function. So the function which is being called is returning, or it's throwing some value to the calling function. Then on the other hand, the calling function must have something to catch it, or we can say a value, a variable who is going to take up that return value. So for that we need to make some small changes in our our demo program, or in the program which is having in the class which is having this main function. So after creation of 2 instances which we have earlier done, we have taken one more variable of type double, and then that variable of type double is named as volume, just VOL, and we are going to do what? We are actually going to catch, or we are going to actually going to store the value which is being returned by the function or the method volume into this vol variable. Now obviously we need to look into the compatibilities. I'll be discussing it further. So here we have seen the new we can say line, or the new statement which is there is VOL is equals to mybox1 dot volume. That means we have called volume function using the instance mybox1, and whatever value is being returned will be stored inside VOL. We have printed that using system.out.println, and in order to get the volume of the second box, we have written vol is equals to mybox2 dot volume, and then again that variable vol has been kind of we can say printed. So here this volume function is actually returning a value, and that return value is being we can say caught here, or being kind of stored inside this vol. And if we talk about the compatibility issues which I was talking about, that has to be carefully carefully looked after. That means the type of data returned by a method must be compatible with the return type specified by the method. So for example, if the return type of some method is Boolean, one could not return an integer. If the return type is Boolean, then Boolean has to be returned. Also the variable at the receiving end, which is going to receive the value returned by the method, such as vol we have just seen, that variable vol must also be compatible with the return type specified for method. So this should not be like this, that within the volume function we are returning an integer, and that integer is going to be in the within the main function, we are going to store that integer value inside a character variable. So, though the variable receiving the value which is returned by a method must also be compatible with that return value. Now, till this point what we did, if you have seen our volume function, we have seen the return type double volume, and we have we can say stored or we just said within one statement that return width into height into depth. So, this approach is actually, I can say, not recommended because of the two we can say the two reasons. First reason is it is actually a error prone approach. That means it is easy to forget to set a dimension. So, for example, we have 7 variables, not the dimension, but 7 variables which are to be accessed inside the method, and we it's a very common scenario to forget to set a particular variable. Also, when we talk about the more sophisticated or well designed Java programs, the instance variable should be accessed only through the methods defined by their classes. Here in we can say when we have seen this program, we have seen mybox1 dot width is equals to 10, mybox1 dot depth is equals to so and so, mybox1 dot length is equals to so and so. That means these instance variables, what we want them to do should be accessed only through the methods defined by their classes. So, what is the solution to this approach? We actually don't want to use this width, height, depth multiplication and returning it inside the volume, which is an instance method, and these three have been assigned the values in the class structure. We need it in a well designed manner. So, basically for that what we need to do, we need we need to add parameters to the method. So, presently our method volume is not having any parameters. Some methods, yes, I agree, they may not need any parameters, but most of them do need some parameters. Now, when we talk about the term parameters, they are way of method generalization. If we are passing parameters while calling those functions, we can have different parameters, and obviously this is a generalized approach, and also a parameterized method can operate on a variety of data that can be used in a number of slightly different situation that can also be done here. So, now in order to see how a parameterized method is going to work, let us see this program. So, here we have class box and double width, double height, double depth. We have we can say declared these two variables. This we have already done, and volume here is having returning a double value which is a multiplication of width, height and depth. Now, moving further, this says we have one more function, I can say, which is there to set the dimension of box. Please see here that we have just declared, we have not said double width is equals to 10 or something of that sort. So, in our main program also we are not going to do that. So, here this says one more inclusion of one more method, which is void set dimensions, and it is taking 3 parameters named as W, H and D, and all these 3 parameters are of type double. And what is happening here, the value of W is assigned to the width, the value of H is assigned to height, and the value of depth is assigned to D. And here our class structure is we can say ending. Now, when we start with the class which is having main function, what are we going to do there? So, we have 2 instances, as we have started some programs back. We are working with 2 instances. One is mybox1, another one is mybox2. So, box mybox1 is equals to new box, and similarly for mybox2. we have one variable VOL, which is kind of a variable which is going to receive the return value. Before calling the function volume, which is calculating and returning the value of volume for these two different instances of box class, we are going to call this method which is setDim, and the this method setDim is actually there to initialize each box. So we will be calling them with the using the dot operator by qualifying them with a instance variable, or we can say the reference variable to the object, as we have called vol, so a volume. So we have in the previous programs we have written mybox1 dot volume, but before going to volume or before calling the volume, because volume is actually giving three multiplication of three parameters, but those three parameters which are width, height and depth are actually not we can say initialized here. So mybox1 dot setDim 10 20 15, and then second statement will be mybox2 dot setDim 3 6 9. So what will be the effect of this mybox1 setDim 10 20 15? Going back to the setDim, the value of W will be 10, the value of the second parameter H will be 15, and value of the will be 20, and the value of the third parameter, which is D, will be 15. And these three values 10, 20 and 15 will be assigned to the width, height and depth of the calling object. So presently this setDim is being called by mybox1. So the variables width, height and depth of mybox1 will be having values 10, 20 and 15. Similarly, when we are calling setDim with mybox2, it is kind of with mybox2 having some different values which are like 3, 6, 9. So 3, 6, 9 will be the value of width, height and depth of mybox2. So using this setDim, what we have done is we have assigned the instance variables using this particular method. Now instance variables have been kind of assigned, have been set. Now what is left is we actually want to call this volume function, and whatever will be returned by that volume function will be stored in a value, and that value will be printed. And this we have already seen in our previous example. The new thing which we covered here is the initialization method, or the method to initialize the instance variable of particular object, and that method is being named here as setDim. So further we will be saying volume is equals to mybox1 dot volume, that means calling of the function volume by using mybox1, then calling of the function volume using the instance mybox2, and whatever value is going to be returned will again be stored into the same variable. Before going into the volume of the second box, the volume of the first box is printed, and then the second one is calculated, being stored in VOL. Although we could have taken two separate variables, VOL1 and VOL2 here, that's also kind of we can say fine, and then that volume has to be kind of we can say printed. So here in this lecture what we did till now is we studied about the return value, that how this return value will be passed from a called function to a calling function, what all compatibility points we need to take care of, and it is not just the return values. Then we have started the how are we going to use some parameterized methods, because those parameterized methods are going to be used for assigning the variables of variables corresponding to different objects. In our kind of initial programs, that was done within the class having the main function, which was actually a clumsy approach. Now here we have separately used one setDim we can say method. We have taken some variables, and those variables have been assigned to the instance variables. Now actually what are we doing here? If you can see very carefully, we are initializing the objects, or we are initializing the various variables of the object using this setDim method. And here object oriented programming languages, Java 2 is allowing object to initialize themselves when they are created. That means as we did in this program just now, that we have used a setDim function in order to initialize the instance variables. We need not to do it through a separate method, rather this can be done automatically. That means object initialization can be done automatically through the use of constructor. So here comes our next topic, which is constructor. So constructor is nothing but actually it is a method having the same name as the class in which it resides. So for example, the class is being named as box, so the constructor is named as box, and it is syntactically similar to a method. Why I am saying it is syntactically similar to a method, I will be telling you in a short while. And a constructor initializes an object immediately upon creation. The moment your object is going to be created, it will be initialized using this constructor. And once you have defined the constructor, the constructor will be automatically called before the new operator completes. Now which new operator I am talking about? Please recall the line box b1 is equals to new box. So whenever I am saying before, once defined, we have defined the constructor, and then we have we can say initialized the objects, created the objects, and on the same time initialized it. The constructor is automatically called immediately after the object is created, that is before the new operator is going to complete. Now as I was saying, it is syntactically similar to a method. That means it must have a return type, but to your surprise, constructor is not having a return type, not even void. That means we need not to write any we can say type wherever this return type has to be written, not even void. Please be very careful with this. This is because the implicit return type of a constructor is the class type itself. That means if the constructor is belonging to the class box, it will be returning the box type. If the constructor is of type, let's say car, it will be returning a car type. So implicit return of a constructor is the class type itself. So that's why we need not to have any return type, not even void. And it is constructor's job to initialize the internal state of an object. Internal state of an object, when I am saying, that means I am talking about the instance variables. So state, behavior, that these terms in context of object we have seen earlier. So when I am saying it is the constructor's job to initialize the internal state of an object, that means whatever variables a particular object is having, it will be a constructor's job to initialize that. And now after that, after creation of object, and instance which is fully initialized or a fully usable object will be returned. So as I have told you that these constructors are basically there for initialization of object. So in order to use this constructor, what change we are going to do in our previous program is we don't need this setDim method anymore. If we are going to use a constructor, the dimension of the box will be automatically initialized when the object is created, we can say. Now let us see how this constructor is working here. So here is the program. We say class box, the three variables that we have seen, and now the constructor of the box. Please notice it very carefully. This is a method. Presently it is not having any parameters, but it may have, and it will have some parameters. Then the name of the constructor is same as the name of the class, which is box with B capital, it is not having any return type also, and within this kind of method or within the constructor, the first statement says constructing box, the value of width is 10, the value of height is 10, the value of depth is 10, and after that the volume function is there, which is going to compute and return the volume. So double volume and return width into height into depth. So the volume is being closed and so is your class. So now within this class we have one particular function volume, which is the multiplication of width height, which is returning the multiplication of width height and depth, and another function which is nothing but the constructor for the class box is being written here. And presently what this constructor of the class box is doing, it is initializing width, height and depth as 10 each. So width is equals to 10, height is equals to 10 and depth is equals to 10. So this is what your constructor is doing. Now the beauty with the construct or beauty of the constructor is you need not to call it separately. So when this is going to be called, let's see. So now inside the class which is having the main function, we have initialized, we have declared, we have allocated two box objects as we did, box mybox1 is equals to new box, and the second one double volume. And now please see that we have directly called mybox1 dot volume. We have not called the constructor explicitly anywhere, and volume will become printed. In order to get the volume of the second box, we say vol that vol variable is equals to mybox2 dot volume, and that volume is also to be printed. Please recall the previous program, we have before applying or before accessing the function volume, we have called the function setDim, because that function was kind of setting the dimensions for these two objects mybox1 and mybox2. Here we have not called, in fact we don't have that setDim function. Despite of this thing, our program, when it is going to run, it will be generating the following results. Now what are the results? So the result says constructing box, again constructing box, then volume is 1000, volume is 1000. So this will be the result. Now why this result? This constructing box is actually the statement which is returned inside the box constructor, and then the value is being assigned to height, width and depth. So when this constructor is being called, for both of the objects or for both of these reference variable mybox1 and mybox2, the instance variables were initialized by the box constructor when they were created. Now when they were created, that means essentially the line when we say box mybox1 is equals to new box followed by parenthesis. So this is the kind of we can say point behind calling new box and this parenthesis. So box and then parenthesis is actually calling the function which is named as box, and that is nothing but the constructor. So that means when we are kind of creating the objects, that is in the line box mybox1 is equals to new box, we are actually calling the constructor in an unknown manner. Till this point we were calling the constructor, and when this constructor is being called, the statement constructing box will be printed, and then the value of width, height and depth will be assigned as 10. So one particular mybox1 is created. Similarly the second one, which is mybox2, is also created, and the constructor gives all the boxes the same dimension, which is 10 by 10 by 10, and both the objects or reference variables mybox1 and mybox2 will have the same volume, and that volume, which is 1000, and again 1000 will be created. So first the constructing box, it is the result of the creation of mybox1. The second statement which is printed constructing box, it is the result of the creation of mybox2, then volume is 1000. This is from calling the function volume using mybox1, and then the last one, which is kind of volume again 1000. This is the result of calling your volume using mybox2. So the new box and the parenthesis is actually calling the box constructor. Now the point is, till this point we have not explicitly defined a constructor for the class, and the program was running fine. So when you don't explicitly define a constructor for a class, then Java creates a default constructor, and that is why our preceding programs did not define any of the constructor, because default constructor automatically initializes all the instance variables to 0. Then we have provided a set dim to have different values to those we can say instance variables. So default constructor is often sufficient for simple classes, as we did in our previous example, but it is not okay for more sophisticated programming examples. And also, if one is defining our own constructor, then the default constructor will no longer be used. The Java system is going to introduce default constructor, or is going to provide the default constructor only if that any constructor from the programmer is not being defined. So here in this lecture we have started with how to have return values for the methods. Then we have seen how to initialize the instance variables using various methods. Then we started with the topic of constructor, and we have seen its utility and the meaning. Here is a list of references which is being used for the preparation of lecture. Thank you for a patient hearing. I'll see you in the next lecture. Till then, take care. Goodbye.